Okay, very good evening to all of you for the masterclass webinar organized by Emertxe. So basically, these webinars we used to organize on a weekends, typically on a Saturday, and this one will also spill over to Sunday. And we have done about 6 webinars in last year, 2022, where we have invited various speakers, working in various companies, and they spoke about various topics. So we kind of, wanted to make like a Netflix series, right? Like a Netflix season, right? to give a different variety of um, topic to all of you. And as I said, these webinars are open for anyone. We have, Emerging students here, Emerging interns here, newbies who, got to know about us by our emails or found us in social media, or some of your friends might have told to attend, right? So we have all the combination of people, right? So today we are kickstarting the second season. So just to give a brief, what we did in first season, we invited external speakers and they spoke on latest technologies. Okay, some of you have attended will remember, or if you don't, some of you not attended, it's fine. Let me just briefly tell. So they spoke about latest technologies. So they spoke about topics like electric vehicle, Linux and open source, how to contribute to open source. Then we had a talk about edge computing. Then we had talk about blockchain, right? So it was more about 2 hours of talk, giving some practical scenarios, giving some use cases, and and share you what is happening latest in those latest technologies, right? That was a 6 episodes, a 6 series of webinars we did, right? So then we kind of took a break, went back to a drawing board. We also received a lot of feedback from participants saying that, sir, next season, can you make it like more hands-on, right? Bring in more coding element of it, or more competitive element into it. When I say competitive element, when you're going to appear for a core job, right, they will ask certain things, right? That's very, very premise in which, Mubin is going to talk today. So we thought, we'll let us start the season 2 as what you call the prep workshops. So we are going to this, starting today, whatever you are going to see in season 2, they're more about hands-on coding, demonstrations and some exercises for you to try, so you can make your hands dirty, and then also these exercises and these webinars will help you to prepare for the core jobs. As I said, no, whether it's a student, intern, or a open registration, doesn't matter. These workshops will definitely going to help you. So that's a theme. The theme is going to be core job prep workshop. So today we are starting the first webinar. This is going to be a 2-part series today and tomorrow. We will further talk about it, right? So that's about the premise in which we are starting that, season 2. And people who are new to Emertxe, because there are a few newbies here, let me just briefly talk about us. We are a tech company. We've been in this field for more than 19 years. At a high level, we are trying to solve 2 problems, 2 very challenging problems. People know who are regular to doing our placement-oriented course. We skill engineers and help them to get into a job, primarily in the field of embedded systems and IoT. And that is for the fresher or the people who are just out of college, or looking to start a career. And that's one segment of people. Then second segment of people are upskilling ones, who are already working, but they're not satisfied with the current job. Either they got into an IT type of a profile, or they got into marketing and sales, and they got into teaching type of profile. Right? They are in a profile which they're not okay with. They want to transition to core embedded industry, right? So they come and take our program and transition into the core industry, right? So that's what we do. And we also have been doing trainings on full stack web development, and we did it just before pandemic. Then we paused it, and very shortly we'll be restarting that as well. Right? So that's about technology portfolio and what we are trying to do. Right? So our leadership team consists of 3 of us. Mr. Maz is the founder and managing director of Emertxe. He heads the organization and takes care of more of the business responsibilities. And myself, Jay Kumar, I'm primarily handle the placements and also handle all these outbound activities like webinars and the internships, etc. And we have Mr. Mubin, who is the technology head, and I'll just briefly move on. Then Mubin will introduce himself and then start. Right. So Mubin is going to be the speaker for today's webinar as well. So that's about the leadership team. And and as you all know, people who have been through the system, we have been placing people over the years in core companies working in various embedded and IoT verticals, automotive, semiconductors, telecom, IoT, robotics, electric vehicles. So that's been our forte, and we have been training and placing a lot of people in these areas. And you can see where our students are getting placed. This is just a snapshot, and then it keeps changing. And even though there are a lot of recession related things are there, the core job segment is doing quite well. I'm seeing already some messages coming in about layoff. Should I be worried? Definitely not. again, that's not the scope of this workshop, right? Probably we'll take it up in some other webinar or in our placements monthly meeting. So absolutely looks fabulous to work with these type of companies and provide them with our trained engineers, right? Trained to aspects of it, right? So quickly talking about 2 more slides, and then I'll hand it over to Mubin to run the webinar further. So why this webinar? So what is the motivation for us to do webinars, right? So one is like, whenever we bring in people, if you attended our past webinars or today, whatever Mubin is going to do, right? So these are all hosted and presented by very senior people in the industry. So they have been there, done that. They really bring in their real-time experiences, hands-on perspective, etc. Right? So which is expected to motivate you guys, right? Basically, there's a mentoring that is happening when you're interacting with them. The chat window is open. I'm sure a lot of questions going to come up as a part of this workshop, this webinar as well, right? So there is a mentoring that is happening. And when the mentoring is happening, there is always some takeaways, right? So what is the action I'm going to do, right? There's a follow-up, right? So that to take the follow-up action, it gives a lot of motivation. So I summarize 2 M's: mentoring by interacting with our mentors or the speakers as a masterclass webinar, and as a follow-up action when you take, right, you do it with a lot of motivation because you are informed, you've been inspired, right? So and spread a positive message, give them a ray of hope, right, and give them the right set of guidance. So that's the kind of a objective with which you've been running these webinars, right? So let me quickly talk about today's webinar. So today's webinar, as I said, will be delivered by Mubin, and I think he also have a set of our Emertxe mentors. I don't know whom he is going to invite. We'll be delivering or supporting him delivering these workshops, and I'll let Mubin introduce himself. Before that, a couple of things to note when it comes to masterclass webinar, just to keep the motivations high. All the participants will get participation certificate, and in digital certificate you'll be getting. Please note, it's only for people who attend. Right, today and tomorrow, this particular tool, GoToWebinar, will mark the attendance, what time you're logging in, what time you will be logging out. So we'll ensure that you're attending some minimum period of time. For them, there will be certificates. Our team will be emailing you sometime next week. Right, this is one benefit. Second thing, tomorrow evening after the webinar gets over, from 9 p.m. onwards, we will run an online quiz, right, based on the topic that Mubin is going to cover today and tomorrow. That quiz will go live in our Instagram page, and I'll be sharing you a coupon code, right? Coupon code I'll share by tomorrow towards the end. So you need to enter the quiz by entering the coupon code, because we don't want this quiz to be taken from anybody who is visiting our Instagram page, right? There should be some merit for you guys, right? So only people who put the right coupon code, which I'll be telling in the webinar, will be evaluated. If you put a wrong coupon code, will be automatically disqualified, right? So people who score well will be shipping goodies. Our team has got a bunch of goodies. They will, reach out to you, get your contact address, or if you're an Emertxe student, probably will hand it over to you physically, or if you're an Emertxe online student or you are newbie, we'll be shipping you the goodies. So that's a additional benefit. This is all, again, as I said, just to keep the motivation high among yourselves. So that's a premise. So please watch out for this quiz tomorrow. I will announce the coupon code just before the webinar gets over, right? Tomorrow around 9 p.m. or 8:45, I'll share the coupon code. Okay. So with that note, let us invite today's speaker, our technology head, Mr. Mubin. Mubin, are you there? Hello.
Yeah, yes.
Okay. So Mubin, over to you. I'll just go off the video, then you can talk over. Probably I'll be in the listening mode. Okay. Have a great webinar, guys.
Yeah. So good evening, everyone, and welcome to today's webinar about Introduction to Competitive Programming. Let me share my slide. Hope my slide is visible.
Yes, moving.
Okay. So not much of a slide, since it's going to be more of a hands-on session. I will quickly touch upon what we're going to discuss in today's and tomorrow's webinar. So before we start, let me briefly introduce me. My name is Mubin Jukaku, and I work as a technology head at Emertxe. I'm a computer science graduate. It's been like 19 years since I passed out from my engineering, and after I passed out, I got opportunity to join Emertxe as a software engineer. So that was immediately after I passed out. I worked here for almost 1.5 years, working in different technology areas, including like device drivers, EDA tools, Bluetooth, Python-based applications, etc. And from there, I moved to other companies like Novell and HP, wherein I got opportunity to work in many applications, primarily in the open source domain. And in HP, I worked for 4 years, and I worked in 2 projects. One is like I worked on an application which was centered upon document workflow management. And after that, I moved to another team which was responsible for developing HP print, scan, fax device drivers. And it was pretty interesting journey because I got to meet like pioneers like Linus Torvalds also, wherein we closely work with the HP team and the HP printer division. So from there, I joined back to Emertxe as a technology head, and it's been 12 years since I'm working at Emertxe, primarily managing the technical team who is responsible for delivering trainings in the area of embedded systems, IoT, and web stack application. So that's a brief about my introduction. So over to like today's topic, it's introduction to competitive programming. And this webinar is going to be held today as well as tomorrow. So approximately we'll have a duration of 4 hours to complete this webinar. So regarding what we're going to discuss in the webinar, I'll briefly touch upon what is competitive programming, introduce you to what is competitive programming, and what are the prerequisites for you to get started with competitive programming. And then we'll discuss about how to get started. So if many of you might not have basically created logins in maybe websites like HackerRank, LeadCode, etc. So let's see how we can get started and solve some of the competitive programs. Then we'll move on to different types of problems. The idea is like we take one platform and get started with some of the easier problems initially, and from there we'll maybe try to solve different types of problems involving different data structures. And in these 2 days of webinar, idea is that you will understand what is competitive programming and how to get started, plus we'll solve some interesting problems in different platforms which facilitate us to try out and showcase our problem solving skills. So that is about the agenda for the webinar. If you have any questions, feel free to ask in the question box. I will monitor them and see whenever if it's a relevant question to try to answer. All right. Okay. So maybe it's not necessary for you to practice along with me, but maybe once you go back and after completing this today's session, you can create your own account and you can practice some of the problems which you are discussing in the webinar. All right. So let me, maybe I'll ask this question to you people. So can you tell me what you understand by competitive programming? Have you heard about this term, competitive programming? Some are saying no, some are saying yes. Okay. So what have you understood by competitive programming? Those who have at least some idea. Okay. So Anshuman says competitive programming needed to crack competitive exams. Yeah, that is right. So yes, have seen some competitive programming in YouTube, says Mohammed Ismail. Okay, problem solving skills, say Hari Prasant. All right. Okay. Yes, so we need to solve questions with time constraints and efficient code. Yeah, deal with problem solving to get problem solving skills. Say it's Saladi Sesha. Okay, which handles large data. All right. So some of you have some idea about what is problem solving. So that is good. So idea is we need to solve certain problems from a diverse set of problem set. Now, if you have created accounts in HackerRank or LeadCode or CodeChef, they will have something called as problem set, as well as every week they will schedule something called as programming contest, right? So to participate in such programming contest, one should be having the capability to solve these problems in a limited time. So time is an important constraint here, because they will give us certain problems in maybe in a window of 2 hours, and you may have to solve as many problems as possible within the limited time. Now, considering your background or our background, like, can we get started with the problem solving using these platforms is the question. If yes, what are the prerequisites to get started, and what is going to be the journey so that you become a better competitive programmer? So that is going to be the focus of this webinar. Now, what are the prerequisites? The question which is put across, right? What do you think is the prerequisite to get started with competitive programming? Let me share another screen. So number one prerequisite is that at least you should be good in a programming language, right? So you should be good in a programming language. Now question comes, which one, right? So it doesn't really matter which programming language you are familiar with. So let's say you can, C, you can basically start with C, or you're good in C++, you can start with C++, or if you know Python very well, you can basically use Python or any other language. For example, let's say you're good in Java also, you can take it. So language is not a constraint to get started with competitive programming, but you should be good in one of the programming languages. Yes, certain languages have advantages over other. For example, if you look at a C as a programming language, it may not be feature rich in terms of like concepts, like it may not support object-oriented programming, or it may not have a rich set of libraries which is built in. Whereas if you look at a language like C++ or Java, you can see that you have many support for additional libraries and data structures which are built into the maybe to the system as such. Now, using C++ may be better compared to C if you want to make use of certain built-in libraries. For example, you can use STLs if you are familiar with the standard template library, etc. You can use that, and you may be able to write less code and get things done. All right. So nevertheless, if you're good in C, not a problem. You can continue with C programming language, and if you know other languages, depending upon your comfort level, you can choose the programming language. So in this audience, can you tell me which all programming languages you are familiar with? All right, some are saying C. right? Many of you are saying C language, C++, some of them C and Python, some are saying Java, all right? Okay, so many are telling C, some are saying C++, C, Python, Java, all right, fine. Okay, so whichever language you're comfortable with, I would suggest you use that language and get started with problem solving. Okay, now as such, there is no dependency between problem solving and programming. Okay, so any programming language can be used to solve a problem. Now, what is the second important prerequisite for you to be good in competitive programming? So one is like you should know a programming language, right? That is one thing. Second thing is in terms of solving problems, you should be able to write algorithms, right? And you should be familiar with certain data structures. Okay, so that is the second prerequisite I would say. Right? Now again the question comes, what all data structures should you know, right? Which data structures should you know? Now again, it depends on how far you want to reach in competitive programming. Now you may be familiar with certain data structures like arrays, right? Maybe linked list and maybe stack, queue, etc. right? To begin with. Now, if you know these data structures only, that is fine. Okay, for example, you know only arrays, you can solve problem using arrays. And you don't know, let's say linked list, it's fine. So to begin with, you can pick the problem sets which can be solved using arrays, for example. And you can familiar with solving problems using arrays. Now, if you want to solve much more basically complex problems, then you may have to learn first the required data structures to solve those problems. For example, linked list or stack, queues, etc. You may have to learn first. Then after learning those data structures, it's better to basically solve the competitive problems related to that topic. Now there are more basically data structures like trees, right? Hashing or hash tables. Then you have graphs, etc. Right? And using these concepts, we can further basically solve much more advanced problems. Now, to get started with, I would say you can start with arrays, then slowly you can move on to basically other data structures like linked list, followed by stacks, queues, trees, hash tables, etc. So these are the prerequisites to get started with competitive programming. So how many of you know data structures? At least what is given in this first line or the basics? Okay, some of them are saying yes, have some idea. Arrays, some of them are mentioning. Okay, some of you are familiar with the data structures. Yeah, some are saying linked list, they know only arrays. Okay, trees, subfunctional stack. Okay, some are familiar with graph also, arrays, stack, and so on. So not a problem. So I'm just laying out a set of prerequisites we should be targeting so that you can get started with competitive programming. Now next comes, how do I get started, right? So there is the next question. How do I get started? We get started with problem solving. What you can do is, assuming you have met the first prerequisite that you're good in problem solving, good in programming, and you know arrays, etc. The next thing what you can do is you can solve easy problems in websites, coding websites like LeadCode or HackerRank, etc., or maybe CodeChef and so on. So there are several platforms which provide competitive problems in different categories. Like they provide problems in the category of easy, medium, and hard. And you can also filter based on type of basically problem, right? For example, you can say it uses certain data structure, like maybe it uses arrays, right? It may use, for example, linked list, it may use trees, and so on. So you'll be able to filter the type of problem from the platform, and from that you can select certain type of problems and solve them first. So idea is whichever data structure you're familiar with, target those, get started with the easy problems first, and if you're able to solve easy problems, then move to the hard, medium problems, and then you can move to the hard problems. Advantage of using these platform is that you can also make use of the features which are provided in that platform. For example, it will allow you to basically see others solutions as well, right? This is very important thing. For example, you solved a problem and you want to see whether your solution is good or somebody else has already solved the problem. So you can see others solutions and you can learn from them. So this is one of the best things you can do when you solve problems on these coding sites. So you can learn from others, and in future, for example, when you get a similar problem, you will be able to apply those concepts and improvise on your logic. Now, a few other things you may have to notice, right? Now, when you solve these problems, important thing to notice that how efficient is my program. So these platforms provide report in terms of how your program stands in terms of performance with respect to the memory usage and CPU usage, right? So efficiency is measured by in terms of CPU, right? Runtime usage and memory consumption. So we'll solve some problems and we'll have a look at the efficiency of our programs. What I'm trying to tell is that, so when you write code, initially you may not want to basically focus on efficiency, but over a period of time, as time progresses, you will have to not just solve the problem, but also you'll have to work on the efficiency of the program. So the platform will generate reports in terms of where your program stands in terms of efficiency with respect to the CPU usage and memory usage. It will also give a comparison report in terms of like a percentile kind of a report mechanism, wherein in the graph, okay, where are you, right? Have you basically implemented a better solution compared to others or not? So I'll show you some of the mechanisms wherein we can write maybe a semi-efficient program first, and after that we'll try to optimize and write efficient programs. All right. So this is a brief about how we can get started with competitive programming. Now what I'll do is I will use a platform called as LeadCode. Okay, so I'll use a LeadCode as a platform. Have you heard about this platform? Yes, some are saying yes. Okay, some are saying no. All right. Okay. So I'm getting yeses and no's, not a problem. Okay. So I will use a platform called as LeadCode, and using LeadCode, what we'll do is we'll try to solve some of the problems. And in between, we'll discuss about some of the concepts which are required to solve those problems. So in general, before we get into LeadCode, let me ask a very basic question, right? What is a program? I know it's a simple question. So what do you understand by a program? What is a program? Okay, so many are saying it's set of instructions, set of rules, it's a language of computer, set of instructions. All right, program is set of instructions. Okay, fine. So what does the program do? So what does a program do? So if you look at a program, right, program takes input. It takes some input, it processes the input and gives you some output. So program takes input or inputs, right? What does it do after that? It processes the input, right? And after processing the input, it gives you the output. Right? So what is input here? It's nothing but data, right? Input is nothing but data here. And how does processing happen? Basically, you write the code or instructions, right? Instructions operate on data. So program is nothing but a mechanism to take inputs, and it will process the input by using some logic and algorithm, and after processing the input is going to give you an output. So input is data, output is also data, right? Both are data. So is that clear? Right? Okay. Now can you tell me what is a function? What is a function? Is a function similar to a program in terms of what it does? Overall, I'm saying. Is it similar? So according to this definition, I told that it takes some input and it's going to process the input and give you some output, right? So if you look at a function also is similar to a program because it takes some input, right? It's going to process the input, it's going to give you some output. A program can consist of many functional blocks, right? So we can use functions to implement the logic, and in a program you will have multiple functions. So program, we saw what is a program, and with respect to function also the same thing will apply, right? A function, if you look at a function is similar to a program, I would say. Function also takes input, right? We call it as parameters, and it's going to process the input, which is nothing but the body of the function, right? And then it's going to give you some output, which could be the return value from the function. That's what it is. Now, the reason I'm reiterating this is that when you're working on competitive problems, they will define the problem statement in such a way that they will mention this is the input, this is the output, and what is that you need to do will be mentioned in the problem statement. It's very important that you understand what is being explained in the problem statement. So let's lay down some basically rules which we need to follow to solve a problem. So what is the problem solving approach we need to take to solve any problem? Okay. So can you tell me what is the approach we need to take when you get a problem to solve a problem? Can you directly start implementing the code, or should we do something else? So I'm getting answers like no, ad hoc and generic. Okay, we may have to write an algorithm, understand the conditions first, obtain the requirements first. Okay, we have to write a pseudo code. All right. So flowchart we may have to write. Fine. So before we start jumping into the code, it's very important that you follow certain steps, right? So that you can solve the problem correctly and in a limited time. So number one step to solve a problem is to understand the problem statement. Right? That is the most important thing. And at times you may find it difficult to understand the problem by reading it for the first time. So it's very important that you read multiple times and try to basically understand what are the input output requirements. And at times they may define a simple problem in a complicated way. So we'll see how to basically read some of the problem statements and try to basically put it in a simple format. After understanding the problem statement, before jumping into the implementation, it's better to basically derive a solution or design or derive a solution. To derive a solution, you can use different mechanisms to represent the solution. I would say, for example, one option is you can write an algorithm, right, which is independent of any programming language, or you can even write a flowchart and so on. Now, after you become an expert, it may not be necessary to basically deep dive or into like writing every detailed algorithm. So this comes by practice. Over a period of time, maybe you will find certain problems very easy, or you may be comfortable in solving problems without writing the algorithm, but at least you can start writing comments in the code as to what you're going to do, following which you can write the implementation. So for beginners, I would suggest write the algorithm first or flowchart first, then you can write the code. So third step is implement the code. So after implementing the code, you can test the code, okay, using test cases which is provided. Okay, so in these platforms, what they do is that you can write the code, and after writing the code, you can give test inputs available in the platform, and if it's working, you can submit the code. So many a time, when you run the code, they will not share all the test cases. Only limited test cases will be shared when you run it. But after you submit, few hundreds of test cases will be executed, and if any one of the test case fails, your code will not get submitted. So we'll see how that is done and how to basically identify the test cases which are not working, and most likely there will be a bug in the code because of which the test cases are not working. So this is the approach in general we have to use for any problem solving, be it programming or non-programming. But in case of programming problems, first we have to understand the problem statement, then derive a solution using an algorithm or flowchart possible, then implement the code. After implementing the code, you have to test the code using the test cases which is provided. So that's about problem solving approach. All right. So what I'll do next is I will log in to a LeadCode account now. Let me pause my screen, and we'll get started with solving some of the problems which are available in the LeadCode platform. Just a second. I'm just logging into my LeadCode account. After that, I'll share my screen. All right, so I have shared my screen, which is leadcode.com/mubinj. This is my basically account. It's a fresh login. I've not solved any problems in this account, so that I can show you how it looks like exactly when a beginner starts. All right. So hope my screen is visible. Okay, thank you for confirmation. So maybe I'll start with the basic problem set initially. Then we'll move on to some advanced problems. If you look at this website, leadcode.com, we have different menu options over here. If we go to explore, you can see certain tutorials are available, right? LeadCode beginner's guide, some other reference materials are also available. Some are free, some are paid. So most of them are like paid, some are free. So you can have a look at these guides and you can get started. For example, look at the LeadCode beginner's guide, right? You click on it. It shows that how to solve the problem. Some guidelines are given here, and it's asking you to basically try with some of the problems given in this list. So what I will do is maybe for now, I'll solve some of these problems which is given in the beginner's guide. Okay, so that you also get familiar with how to get started. Then we'll move to different problems given in the problem list. So if you look at the problems area, clicking on the problems area, we can see that there are thousands of problems available, and it shows like what is the difficulty level of each problem, and accepted solution also shows. So don't look at the solution initially, right? Many people have a tendency to look at the solution, so don't do that. Please don't look at the solution. Now, some of the problems, there is explanation of the solution in video format. So you can see this icons, right? So this is like solution is there. This means there is a video. So there will be video explanation for the solution, etc. Acceptance frequency is there. Frequency is not shown here because it's not a paid account. So frequency will tell you whether these questions are frequently asked in company interviews also. So if you go for a paid account, it will show you, okay, which are the frequently asked interview questions. That also you can see. Here also you can filter based upon what type of problem you want to solve, like algorithm or database or shell, concurrency, etc. Here also you can see there are certain filters, right? Arrays, strings, hash table, dynamic programming, and so on. So in short, it's a very good platform wherein you have a lot of problem choices based upon the interest level or based upon your capabilities. You can pick the problems and you can solve it. All right. So let me go back to this screen first, solving your problem first. So it's okay. I'll click on this, solving your problem first. Okay. So it will open up. It will show some basically videos, etc. And here you can see it's asking me to solve add two integers problem. That's okay. So we'll get started with a simple problem so that we know how the interface looks like. Okay. So in any I'll skip this for now. In any platform, you will find an interface similar to this, wherein they will have the problem statement explanation given in one basically side, and an ID will be there on another side. And this ID, you can write the code. You can also test the output here. So here there is a option to choose the programming language. So you can see different programming languages are supported. So I will choose C here because most of you are familiar with C. So I will choose the C programming language. And if you are familiar with some other language, you can change the programming language. So any programming language which you are familiar with, you can choose, and you can continue with the solving the problems. And here, if you look at the left-hand side, you can see a number 2235. Right, this is the problem number. Add two integers. We are going to solve. So given two integers, let's read through the problem statement. Okay. So initially, I'm going slow. Then later on, we'll solve much more advanced problems. The idea is to get familiar with the environment first. Then we'll switch to much more complex problems. So given two integers, num1 and num2, return the sum of two integers. Example input is here. Num1 is 12, num2 is 5. The answer should be 17. Here it shows another example with negative numbers also, right? -10, 4, and output is 6. After adding these two, we'll get 6. Constraints, some constraints are shown. Number will be less than, num1 will be between 100 to -100 to +100. That is good. So this problem is not complex. Let's solve this easily. Okay, return, I'll do return num1 plus num2. Okay, so notice here there is no main, right? If you are writing code, usually write main, and I also write the function definition. So here observe that we only have to implement the function, right? Function takes some input, function gives output. So you should know what is the input the function expects and what is the output you should be returning. So let me run this code. I'm not doing any other changes. Run the code. Okay, so you can see accepted on the right hand side. Input num1 12, num2 is 5, output is 17. Okay, so it's working. So test case 1 is there. Let me move to the second test case. You can click on it. Look at the second test case. It shows input is num1 is -10, num2 is 4, and output is -6. So expected output and the actual output is matching. So I can do a submit here. Nothing much to discuss here. Let me submit. Right. So it will execute many other test cases. Unknown preprocess compiler. Let me try it again. Yeah, so you can ignore the previous error, right? So here you can see after submitting, right, it shows some report, right? It shows like what is the memory consumption and what is the runtime, 4 millisecond it took, and where is your basically program efficiency in terms of runtime. I'll skip this for now because this is not a very complex problem. Let me move to the next problem. So I'll close this window. I'll choose another problem to solve. Slowly we'll solve much more complex problems. Let me move to the next question. Let's skip this for now. Challenge problems are there. Okay, so here. Okay, so this one, let's try to solve this question. Okay, so running sum of 1D array. So this problem is based upon arrays. So you can look at the problem statement here and the input output expectations. Then we'll try to solve this. So let me grab a glass of water. All right, so here, if you look at the problem statement, running sum of 1D array, given an array of nums, right? It says there is array nums. We define a running sum of array as running sum of I is equal to sum of nums of I to nums of 0 to nums of I. So let's look at the examples, then it will be much more clear. So input is an array 1, 2, 3, 4. Output is 1, 3, 6, 10. So what it does is it's going to take the input array and create another array. Okay, it's going to create another array. So what does the output array contain? It contains the running sum. For example, the first element of the output array will be 1. Second element will be sum of the previous two numbers. Third element will be sum of the previous three numbers. And the fourth, basically, output will be, fourth index element will be the sum of all the elements. Now another example is given. Let's have a look at this. Right, 1 1 1 1 is the input. So you can see what is the output. So how is the output calculated? So with the first index only 1 is taken. The second index it's 1 plus 1. Third index it is right 1 plus 1 plus 1 and so on. So let's try to basically solve this problem. And did you understand the question? If not, let me know. Have you understood the question, all of you? Okay, some are saying, many of them are saying yes. I got a no also. Anybody? Okay. Okay. So here, if you look at the input array, it's 1, 2, 3, 4, right? And output is calculated from the input. So output's first value of the output is 1 itself, right? First element. And for the second index in the output, we have to add the first two numbers, 1 and 2. So 1 plus 2 is 3. 3 will get stored here. You can see here, right? Similarly, for the third output element, we have to add the first three numbers, 1 plus 2 plus 3, right? 1 plus 2 plus 3 is 6. 6 comes here. Similarly, for the fourth output element, it is the sum of all the four elements, 1 plus 2 plus 3 plus 4, which is nothing but 10. It comes up here. The question is, how do you basically calculate this? And there could be multiple ways to solve this problem. But if you look at this running sum, right? So we are storing the output here in the output array, and the next sum is nothing but the previous sum plus the new element, right? Previous sum plus new element, which is 2. So 3 can be obtained, for example, 3 can be obtained by using 1 plus 2 over here. So let me use the whiteboard. Okay. Right, so let me write it down here. For example, we have 1, 2, 3, 4. So how do you calculate the output? So what I can do is, okay, first element anyway, right, in the output, this is the input array. Input, right? So how can we calculate the output is the question. To calculate the output, let's say 0th index the output, we can take the input of 0 only, right? So what about output of 1. So output of 1 is nothing but, if we see, I have to do 1 plus 2. So in this case, let's say output of 0 we are taking. Output of 0 is nothing but input of 0. So output is nothing but 1. Right? That's what we're doing. So output of 1 is nothing but input of 1 plus what is the question? Can you tell me? Yeah. So I'm getting multiple answers here. So Sridevi is saying output of 0. Durga is saying it's 2. Okay, output of 0, output of 0, input of 0. Yeah. So one option is to take input of 0. So, but should we take input of 0? Is the question. Because it's an accumulated output, I can take output of 0, right? So you can accumulate it. Yes, we can do input of 0, but input of 0 is nothing but output of 0 actually. So this approach may not help. Okay, so instead of doing that, I can take output of 0, because output of 0 already holds the running output. Okay, which is nothing but, in this case, 2 plus 1. Similarly, if you look at output of I, right, it's going to be what? Input of I plus output of I minus 1. All right, so that is the solution. So let's solve this. Hope this is clear. So let's solve this in LeadCode. Now here, important thing to understand is in the examples they are giving input as an array, output as an array, right? Here you can see here the parameters, right? In case of C, nums is the input, because it's here also it's nums, so it's matching, right? Num size is nothing but the size of the array, and return size is nothing but the size of the return array. Now this may be a little difficult to understand, because certain parameters you may find it not very much documented, but based upon the input output explanation given here, you'll have to understand what is the input and output. So what I'll do is, to make things very clear, let's basically write down what is the input and output, right? So nums is nothing but the input array. All right, so nums is you can see nums is an input array, and num size is the input array size of nums, right? And we have output. Now what is output here? Output is nothing but return value. Okay, here there is a note given here, return array must be mallocked, assume caller calls free. So the output array we need to allocate dynamically. That's what is given. So I will be allocating this array by using malloc and returning the pointer to it. All right, and one more parameter is there, which is return size. Okay, return this parameter, return size is nothing but the size of output array. Okay, so I will write the code, then you should understand gradually. Okay, so first thing is we need to run a loop, right? So I can declare a variable int I, right? So I'll run a loop for I equal to 0, I less than num size. Better to copy. Auto completion is not supported here. Only in premium version it's supported. That's okay. I plus plus. Right. So I can maximize the screen also so that it becomes larger. Okay. All right. So before doing that, I need to allocate an array, output array. I can say int star output array is equal to, you can dynamically allocate the array. So input array size and output array size is same. I can say size of int into num size. So please note, we are creating the output array dynamically using malloc. Okay, I'm assuming that it's going to be successful, not doing error handling for now. We can do that. We can do error handling also. Let me try. So if, for example, output array equal to null, I can say return. So we're not printing anything. So it's very important to make sure that we're not printing any values here. Okay, don't print any debug statements. Should not be doing that. Only for testing you can do it, but later you can remove it. Okay, because the output is determined by the return value. So we created an array which is nothing but the output array, right? Int star output array is equal to malloc, right? We're creating an array, then we need to fill the output array. So you can say output array of I is equal to nums of I. Now there will be an exception here, right? So what is the exception? Will it work for the first element also, this logic? Will this general logic work for the first element or no? No, it's not going to work, right? It's not going to work. So what can we do? What should we do? So one option is we can take it out, right? We can take it out. That is one option. One option is we can take it out. So I can say, for example, output array of 0 is equal to nums of 0. This is one option, right? So it's an exceptional case, we can take it out. So then I can do I is equal to 1. So first element is a special case, we can take it out. That's one option, right? And for the remaining indexes, we can use the general formula. So it's going to be what? Nums output array of I is equal to nums of I, which is nothing but input plus the previous accumulated sum, right? So this should work. So we are able to use the general formula. So now here there is a return value which is expected. So what do you need to return? We have to return the output array. You can say return and the output array. Is this clear? Do you have any doubts in this? I minus 1. So yes, correct. So it should be I minus 1. Thanks for correcting. Yeah. All right. So it should be I minus 1. All right. Now we can see there is a return size parameter here. So which is actually the size of the output array. This also we need to set. Now often you will find this to to be not documented. All right, so but we will return it. I can say star return size. So return size is a output parameter. I can say is equal to num size. The size of the output array and size of the input array both are same. Okay, so return size is an expected output parameter. Okay, size of output array. So let's run this code. We can see test cases are passed, right? So to case 1, nums input array, output array, expected output, you can see, right? It's working. Similarly, case 2, all are ones, right? Expected output, you can see 1, 2, 3, 4, 5. It's matching. So all 3 test cases are passed. Then can go ahead and submit. Okay, so I can do a submit here. All right, so if it's submitted, you can see that it shows the code and also gives information as to how is your performance with respect to others who are submitted, right? It shows it beats 16.87% of the people who are submitted, right? In terms of memory usage, in terms of CPU usage, 81.92% efficiency. So I can click on this. If I click on it, okay, it shows runtime and memory basically performance, right? So you are here, it shows, right? 23% of solution use 7 milliseconds of time, right? There are, you can see, right, where we stand in terms of performance. So we have like our solution is like 81.92% efficient compared to how others have solved it. Okay, so it's a comparison chart. Okay, somebody has solved in like 0 milliseconds also. This program is very efficient maybe. So if you want to look at others program, what I can do is click on this, right? I clicked on it and there is a much more maybe efficient solution. But what this person has done it is that he's not created a additional array. He is modifying the original input array only, which is not correct in fact, because return array must be malloc as given. Assumer caller calls free. So he is violating the requirement, which is not correct in fact. So I just wanted to show you that we can look at other solutions also by clicking on it, and you can say, for example, this is another solution, right? I can click on next and so on. You can have a look at somebody else's solution in case you want to understand how other people have written the code. All right. So this is our solution. This works fine. It has passed all the test cases. So I just showed you a problem using arrays, and we are able to solve a problem in LeadCode with not much difficulty, right? So here we created the output array dynamically, and we ran a for loop to calculate the accumulated sum, and we returned the output array. So notice one more thing, we are not simply returning the output array, we are also returning the size by using the reference parameter here. Star return size equal to num size. So hope this is clear. Anybody has any questions? Can we move to the next problem? Clear? Okay. So notice we are not implementing the main, somebody is going to call the main, and in the main they will be invoking the test cases and trying out the output comparison. All right, let's move on to the next problem here. So notice some of the problems, there is a video explanation also. We can have a look at the video explanation if you are interested also, but not all. Okay, only some of them will have video explanation. Okay, now this next problem is richest customer wealth. Okay, some problem is given. Let's try to basically solve this problem. Okay, so I'll go to this richest customer wealth problem. Let's try to understand this problem statement. So richest customer wealth. So this I think is a problem related to two-dimensional arrays. You are given an m into n integer grid. The 2D array is of size m into n. And size of the array we can see later. And array name is accounts. That's a two-dimensional array called accounts, where accounts of ij is the amount of money in the ith customer has in the jth bank. Return wealth that the richest customer has. Okay, I'll explain it later. Once again, a customer's wealth is the amount of money they have in all their bank accounts. The richest customer is in the customer that has maximum wealth. So what they are saying is that a person can have multiple bank accounts, and in each bank account there is some money. So let's take this as an example. Okay, 1 2 3 3 2 1, or maybe take this one. Okay, this. Let's take accounts. So richest customer problem. Let's try to understand what this problem is. All right, so in case of richest customer, so this array is nothing but the accounts array. All right. All right. So this accounts array has 3 rows in this case, right? Row 0 you have, row 1 you have, and row 2 you have. The first customer, if you look at the first customer, has a wealth of 6. So 1 plus 5 is nothing but 6, right? Second customer has a wealth of 10. Third customer has a wealth of 8. How is the wealth calculated? Just add the column values. Okay, so 0th customer has a wealth of 6, 1 plus 5 is 6, and first index customer has a wealth of 7 plus 3, which is 10, and the last index customer has a wealth of 8. Now who is the richest? So richest customer is the one which is having a wealth of 10. All right, so our answer is nothing but richest or maximum wealth, which is nothing but 10 is what we need to return. Okay, so we need to return the maximum wealth for a customer. So you need to use a comparison algorithm here to compare the wealth of each customer, right? So for example, 6 will compare with 10, so the maximum wealth will become 10. 10 you'll compare with 8, maximum wealth will remain 10. So it's a comparison logic which you have to implement. But only thing is, you have to first find the wealth of each customer, then compare with the wealth of the next customer, and so on. So what do you think should be the logic here we have to do? So one option is we can create another array, right? So this can be, for example, this can be stored in another array. Then you can implement a logic to find the largest number in an array, right? That's one option, option 1. So option 1 is to create a 1D array and store wealth. Then find the largest number in the array. So this will work, but this is not very efficient, right? Because you have to separately find the store the 1D array. Instead of doing that, we can go for another option wherein we find the wealth and compare with the next person's wealth. Without storing, without storing in an array. So we'll use the option 2, which will save the one-dimensional array. Instead of storing it in an array, we'll compare on the fly. All right. So let's see how we can do that. So give me a moment. All right, so here let's look at the function prototype. Now there is no information given here as to what is what, etc. So we have to understand on our own. So return value, you can see, right? It's returning the wealth 17 here, 10 here, etc. So in this case, so we need to make sure that the output is nothing but the wealth, which are maximum wealth we have to return. Now there are three input parameters here. Three parameters are there, right? Let's try to understand what these parameters are. Okay, so accounts the 2D array, right? Then account size. This is a little confusing. There is account size, it's nothing but number of rows. Okay, account column size is also there. Account column size is number of columns. At times things may not be very straightforward. In fact, they should not have done this. Actually, they could have directly given us int accounts column size, because we are not going to change it. It's a pass by reference. That's okay. This is maybe a mistake by them. Both should have been integers. Instead of both making integers, one they have made a pointer, but we'll ignore it. We'll use it like an input parameter only. So all three are inputs. These are all inputs. Three input parameters are there. First is a two-dimensional array. Second is the number of rows. Third is the number of columns. Only thing is they didn't give pass by value here. They use pass by reference here. We can ignore it for now. So we need some variables to store the wealth, right? I can say wealth. I can store as a variable. Then we need a variable to store max wealth also. So max wealth will store. So wealth will be wealth of the one row. Max wealth will be the maximum wealth. So some constraints are given here. The length, right? The 2D array size will not be greater than 50. You can see here. The maximum size of the two-dimensional array will be 50 cross 50 can be the maximum size. And each element value is a positive number. That's what they're given here, right? So notice this: accounts of ij, the account value will not be negative, it is going to be positive. So it's not going to be a negative value. All right, so let's start calculating the wealth first, right? So I can say I need some more variables ij to iterate over the 2D array, right? So you need to run a 2D array. You can say I is equal to 0, I less than account size and I plus plus, then we can say for j equal to 0, j less than, here it's a little tricky, this column size, this pointer is given, so we have to use this. Okay, it was unnecessary, but we'll use it for now. Okay, so two-dimensional array, we need to iterate. So you can say wealth, we need to calculate what? Wealth. So you can say wealth is equal to 0, wealth plus is equal to the accounts. Basically you're finding the sum of the row, right? Accounts of I and J. Is this clear what we have done so far? So you're finding the sum of a ith row. So far, did you understand? Some are saying no. Okay, Sadat Fatima says no. Can we bank numbers and amount to get total wealth? So 2D array concept we should be clear with. Here, please understand that this accounts is a two-dimensional array, right? So in case of C, to pass a 2D array, use a double pointer in star accounts. That is the syntax. Okay, you can consider this to be a two-dimensional array. You're passing the reference to a 2D array. So accounts is a two-dimensional array's reference. So accounts of I will be the ith row. Accounts of I of j will be the ith row, jth element. So this you can consider to be rows, right? This is like m cross n. Okay, so here this is like number of rows, this number of columns. So outer loop is to iterate over number of rows, and inner loop is to iterate over columns here. Okay, so wealth is a temporary variable. We are initializing it to 0. Wealth is equal to, plus is equal to means wealth is equal to, I can make the syntax like this, right? Wealth plus accounts of ij. This will calculate the wealth. After calculating the wealth, we need to basically compare with the next or previous row's wealth. So here we can see previous, in case of the first row, there is no previous row, right? 6 is the wealth. But if we look at the second row, 10 should be compared with 6, all right? So I think you're familiar with this logic already, most of the people. So I can take, for example, wealth is equal to 0 initially, because we know it's not going to contain negative values. So I can say after the loop, and I can start the index with 1 here for now, and I'll say, for example, that's okay, I can start the index with 0, not a problem. I can say compare wealth with previous max wealth. So this is how you typically do for the finding the largest number in an array, right? So I can say if wealth is greater than max wealth, what should we do? What should be wealth now? Max wealth, right? Sorry, max wealth is equal to wealth. All right. So loop will run row number of times. For each row, we are calculating the wealth for that row, After calculating the wealth for that row, we'll compare with the previous maximum wealth. The new wealth is greater than previous maximum wealth, we'll update the max wealth. So in the end, we have to return what? Max wealth. Let's run this and check if it works. Yeah, this works, right? You can see here. First case 1 2 3 3 2 1, output is 6, right? Both are same. In fact, 1 plus 2 plus 3 is 6, 3 plus 2 plus 3 1 is also 6, so output is 6. Let's look at the second test case, right? Look at the second test case, the one which we took, right? 6 1 plus 5 is 6, 7 plus 3 is 10, 3 plus 5 is 8, so 10 is the largest. All right, so this is an example how we can use a two-dimensional array problem and solve it. It's not a complex one, it just illustrates how to use a 2D array. Notice the parameters are not properly passed here, because here pass by reference is used, which is not necessary. Okay, that's only issue with the code. All right, so hope you understood. Let's move on to the next problem. Is this clear, or do you have any doubts? Okay, fine. Let's move on to the next problem. Okay, FizzBus. I think many of you would have already solved this. So maybe I'll skip this. Okay, skip FizzBus. I'm going to Fizz. I'm going to skip. You can solve it on your own. Maybe I'll try another one. Okay, this number of steps to reduce a number to 0. Okay, slightly different problem. Let's see. Okay, so given an integer num, return the number of steps to reduce it to 0. Okay, let's see what it means. So number is given, we have to return the number of steps to reduce. You have to make the number as 0. Okay, a number is given, you have to make the number as 0 by executing certain steps. In one step, if the current number is even, you have to divide it by 2. Otherwise, you have to subtract 1 from it. Okay, the number is even, we have to divide the number by 2. For example, the number is 10, we have to divide the number by 2. Otherwise, we have to subtract 1 from it. Let's take an example, right? It is clear if you understand by using an example. All right. See here, number is 14. Number of steps to make it 0 is 6. Idea is you have to make it 0, right? By executing the steps. What are the steps? Number is even. 14 is even. Divide the number by 2. What do you obtain? 7. Next step, 7 is odd, right? Where is odd? Do not divide by 2. Instead, subtract 1. So 7 minus 1 is 6. Again, repeat the step. 6 is even. Divide by 2. What do you get? 3. 3 is odd. Subtract 1. You get 2. 2 is even. Divide by 2. You get 1. 1 is odd. And subtract basically 1. You get 0. So hope you understood the question. Right? If the number, we have to reduce the number to 0. Finally, we have to make the number as 0 by executing these steps. Only 2 steps are there. Number is even, divide by 2. Number is odd, subtract 1. Okay. Another example is given here. You can see 8 is an even number. Divide by 2, you get 4. Divide by 2 again, you get basically 2. Divide, since it's even, right? Since it's even, you have to divide by 2. In the end, you get 2 divided by 2, you get 1. 1 is odd, so subtract by 1, you get 0. So what do you think the logic should be here? It's pretty straightforward. What can we do here? So what do we have to count? Number of steps is what we need to count. Okay, how many steps are required? So what we can do is I can take int, for example, I, right? I can say for I equal to sorry, we can take a no, it's not a for loop. Okay, so we can take maybe a variable called as count is equal to 0. Okay, and idea is we need to make the number as 0. So we can run a loop while num not is equal to 0. So while number is not equal to 0, we need to repeat these steps, right? We need to repeat these steps. So can you tell me what should we do? Yeah, so I got multiple answers here. We need to check if number is even. If it is even, divide by 2. Otherwise, subtract 1. Right? So we need to check if it's even or odd. So how can you check if it's even or odd? So we can use modulus operator. Right? So you can say if num modulus 2. Right? So if num modulus 2, what can we do? That means it is odd. If it's odd, we can subtract number, right? Else can do num is equal to num by 2. Okay. Important thing is that we need to count how many times loop runs, right? And we can return the count. Is this fine? So if it is odd, we decrement number. If it is even, divide the number by 2. Irrespective whether it's even or odd, we are incrementing the count and we are returning the count. Is this fine? Okay. All right. So we can also use bitwise operators. For example, instead of divide by modulus by 2, we can say num or 1 also, right? That will also work. Okay. So another option is you can use bitwise operators. Okay. So let me run this. All right. So test cases are passed. I can submit. All right. Okay. So it's working fine. No problem. So let's close this. Yes, your program beats 8.45%. It's not that efficient. We can make it more efficient, but let's not worry about it. So maybe one way to make it efficient is use bitwise operators. So if we want to change it, for example, I can go back here, go to the description. Instead of basically modulus 2, I can say num or 1, right? Bitwise, for example, to check if it's odd or not. If the last bit is 1. Sorry, num and, right? So this is another way to check using bitwise. Okay, number is odd if LSB is 1, right? So you can check num and with 1. Let's run this, see if it works. Right, it works. So this is maybe a little better logic. That's it. Fine. So let's move on to the next question. We solve these. So as you solve, you can see here, you can see how many problems you have solved, right? We have solved 3 problems so far, right? It shows information. Easy, 3 easy problems we have solved. Let's move on. Okay, so next one is a linked list problem. Okay, middle of the linked list. I think you might have done this if you have completed your data structure assignments. Let's have a look at it. All right. So if you're not familiar with linked list, not a problem. Okay, it's not a very complex topic. Okay, I will first read the problem statement, then maybe give a brief idea of how we can use linked list. So here, given a linked list, for example, it's given linked list 1, 2, 3, 4, 5. There are 5 elements in the linked list, or 5 nodes in the linked list. You have to find the middle element of the linked list. How can you find the middle element of the linked list is the question. Okay, given the head of the single linked list, return the mid node of the linked list. If there are 2 mid nodes, return the second mid node. Okay, so it's little different. So 1, 2, 3, 4, 5, 6 is there, right? So if you look at 3, 4, 5, 6, here it's like very clear. The mid node is 3. Here it's like mid node, since there are 6 elements, mid node is not single value. It can be 3 or 4, right? So it's telling return the second mid node because number is even here. Okay. Here number is odd, so you get the mid node as the third element. Here number is even. You have to choose the second number from the middle, right, which is nothing but 4. So how do we solve this problem is the question. Okay, so let's have a look at the function middle node. Only the head of the node is given, and we have to return the middle node. Okay, so in case of a linked list problem, so usually they will give a structure which is nothing but the node, right? Here you can see node, list node is given, which is nothing but a single node which has a value and a next. So in case of a linked list kind of a problem, so unlike arrays, in a linked list you have something called as nodes, right? I can, for example, add a linked list with a value like this 1, and after 1 there we can create one more node which points to the next node. This is a data structure which is commonly used to store data on demand. So here 2, example, I can create multiple nodes. I don't want to go into detailed explanation. People who are new, I'm just explaining. Okay, some of them not attended data structure module. All right, so here if you observe, okay, this is what a linked list looks like. So in case of a linked list, you have a node which contains a value and which also has a pointer to the next node. So this we can call it as a node. So node dot val is 1, node dot next is the next node. So we can iterate in using a linked list like this. I can say while, right? Maybe some basically pointer like head or while node, right? I can do this, right? We can iterate in the link using linked list. For example, node is equal to node pointer next. So we cannot basically randomly index into the linked list by using an index. Instead, we have to use a mechanism to basically jump from one node to another, right? And read and access the values. That's what we need to do. Now, this program requires you to have some basic understanding of linked list data structure. So let's see how we can find the middle node. So can you tell me what is the logic to find the middle node? Because there is no size option here. How do you find? What is that we need to do? Any idea? So what typically we do is that we don't have a mechanism to basically just find the sum by 2. Mechanism is not available. Instead, we have to calculate the basic or reach to the middle node by using 2 pointers. So let's write the logic here itself. All right. So we can make use of 2 pointers. One is called the current pointer. Okay, and other is we call it as maybe a fast pointer. Current and fast pointer. So what we'll do is that we will use one pointer to move to the next node, and we'll use another pointer to jump to the second node. So one pointer will point to 1 and the fast pointer will point to 3. So let me explain it using a simple illustration here. So I can say 1, then 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing to 5. Let's assume this is the linked list. So initially what we can do is we can use 2 pointers. One is the current pointer, other is a fast pointer. So both are pointing to 1, right? Both will be pointing to the same node. But we'll move fast 2 times compared to current. So idea is you need to reach here. Current should reach here, but fast will move twice. Current will move once and fast will move twice. Okay, current will move once and fast will move twice. So what do you think will happen if we move fast twice and current once? Who will reach here first? Right. So current we are moving only once, fast will move twice. So fast will reach the end first. Let's assume fast reached here after moving. Where will be current? In the mid, right? In the position of 3, because exactly we're moving it twice. So if fast reaches the end, current will be at the middle. That's the logic we're going to use. Okay, so current will reach here. So it may look pretty simple because we have to move twice, current has to move once, right? To move the pointer, we can say current is equal to, for example, current pointer next, right? Similarly, to move fast, what can we do? Fast is equal to fast pointer next. We'll have to do it how many times? Twice. So this we have to run once, right? So current will move only once and fast will move twice. But there are issues. What will happen if only one node is there? Can fast move twice? Or what will happen if it already reached maybe the last but one node? Can it move to the next node? No, right? So we have to take care of that scenario, right? We need to check whether it's null or not. Only then we have to move. If it's not null, we can move, and so on. So let's implement this logic. Let's see. It may not be possible to implement one shot, but let's try our best. So initially, what I'm going to do is we'll take this pointer. Okay, so we will maybe solve this problem here today. Tomorrow we'll take some more problems and try to solve little different type of problem. All right, so let's solve this. This node will take, for example, current star fast. So we'll do current is equal to fast is equal to head. So both are pointing to the first node. Okay, so we need a loop. What is the loop we need? While we can say fast not is equal to, we need to check whether it reached end of node or not, right? This is how we check in linked list, right? Reach end of list. All right, so we can check. So if it is not null, that means it has not reached the end of linked list, right? Now there are other basically scenarios we may have to check. For example, list is empty, right? This scenario we have to check. Only one node in list, right? Such scenarios may also occur, right? So let's make a note of it, because at times other scenarios we'll have to check, right? Number of nodes in the list range is 1 to 100. It would be 1, or it could be between 1 to 100. Okay, so maximum 100 elements it's saying. It can be 1 or it can be 100 also. So let's write the logic for that. So what can we do? We can say current. So can we say current is equal to current pointer next directly? Is that fine? Fast is equal to fast pointer next. So we can do this actually. We can say if fast, right, move one more time. So before moving twice, it's important to check whether we have reached or not. Is this okay, or there is something wrong here? Return, we can say current. Let's try. Okay, I don't think it will work in all scenarios, but let's try. Let me run this. It says wrong answer, right? You can see, right? 1 2 3 4 5. It says output is 4 5. Okay, expected output is 3 4 5, right? In case of this case 2, it's working. 1 2 3 4 5 6. The middle node is basically 4 onwards, right? Output is 4 5 6. So it didn't work in all scenarios, right? We have to read the documentation again. So if it is 1 2 3 4 5, we should return 3, whereas we are returning 4, right? We are not returning 3, we are returning 4. So there is some mistake. We return 4, we did not return 3. So what should we do? we should odd numbers are not getting, right? So that's what some of you are saying. Fast pointer null, next not equal to null while condition. Fast not equal to null, I'm checking. Instead of that, you're telling fast pointer next not equal to null. So we can do that, and fast pointer next not is equal to. Is that what you're saying? Let's try. Okay, so it's working fine. So what we did is we are checking whether fast has reached the null or fast pointer next is null. Okay, so then it works. Let's try to submit this. Yes. Okay, so this code is accepted. If you look at the efficiency of the code, right? So like our solution is best, right? That's what they say. Okay, so our solution is best solution. It beats 100%. It's a very efficient program. So we're able to implement in LeadCode. We're able to reach here, right? That is good. So anyway, it's if you do it in some other programming language, it may not be that efficient because C is very efficient. That's why it's coming here. If you use some other language, even though it's efficient, right, it will not come up here. So our logic is correct. So we are checking whether fast or fast pointer next is reaching null. If it is reaching null, then we will not move, right? We already reached the end of the node, right? So then we get the current node. So you can try out more problems, and tomorrow we'll continue. So today I think we solved some 4 problems, right? Tomorrow we'll try to solve some more problems, and we'll solve some medium and hard problems as well tomorrow. So hope you got an idea how to get started with problem solving in LeadCode, and I would suggest you create your own accounts. All of you can log in. You can just do a sign in using social login, and you can try to solve problems which are available in LeadCode, and this will help you to basically clear interviews in future. That's the whole idea. The whole idea of basically doing this exercise, that at least whoever attended this webinar should be able to get started with the platforms like LeadCode, HackerRank, etc. And by solving more and more problems, you will be able to clear interviews without much difficulty. That's the whole point. All right. So hope you understood what has been discussed in this session. Any feedback for today's webinar? How did you find it? All right, informative and interesting. It was good. Excellent, very helpful session. All right, informative, more helpful. Conduct daily. Okay, it was good. Okay. So thanks for all your feedback. We'll continue tomorrow, and we'll try to solve some more problems so that you also get familiar with solving different types of problems. And please continue on your own as well. Okay. Yes, maybe data structures. I took a linked list problem. Maybe we can solve array related problems also, which is not related to linked list. Tomorrow we'll see some more problems. All right.